Let's start this video by warming up. For problem number 1, this is like the previous video where you're just going to graph a linear inequality. And then for this second problem here, you have a system, and so I need you to find the solution by graphing. So go ahead and pause your video and do these two problems. It will really help with the material you're about ready to see. Okay, here are my answers. Number 1 seemed pretty straightforward, except I have not shaded yet. So remember, you need to test a point. And if I tested 0, 0, you can see that that would be a true statement because 0 is less than or equal to 3. So we should shade this one below. And then for the second one, it's kind of hard to see where the solution was, especially since I'm using an iPad to create this graph. But I kind of anticipated it to be around 0 and 1/2. I'm sure you got a different answer, but just make sure that you've graphed it properly and that you wrote a solution as a coordinate pair. So this lesson is a combination of two lessons you've had before. First of all, it is putting a system, so that means two equations, together, and it's putting the idea of the linear inequality together. So to solve a system of linear inequalities, you begin by graphing both graphs. And remember, solid line, dashed line, and you're just graphing in slope-intercept form here, so this shouldn't be a big deal. Let's start with equation number 1. So my y-intercept is a -2, and my slope is up 4 over 1. And this line should be dashed. And then we're going to test this one, so I'll keep it color-coded. And I will test this one, let's see, with 4, 0. So I'm looking at this point right here to see if that is the side that contains my solutions. So substituting in 0 for y and 4 for x, and then you get 16 minus 2, which is 14. Is this a true statement? Well, 0 is less than 14, so my solutions will be on this side of that dotted black line. Alright, let's graph the second one now. And that one would be at 1 for your y-intercept. And I have to go down 3 and right 1. This one, however, is going to be a solid line. So I'm just treating these as two separate inequalities. And at the end, we'll put them together. So I need to test a coordinate pair for that one. And I will pick, let's say, a -4 and a 0. So I'm checking this as a test point for my red solid line. So putting a -4 in and a 0 in for 3. Cleaning it up. The question is this true? Is a -4 greater than 1? Well, that answer is no, so I'm going to shade on this side of that red line. So for the system, the solutions for the entire system are where your shaded regions overlap. So my solution for both of them together, well, my red and black overlap here. So it turns out to be more like a quarter of the plane. You can see here's an edge here, and there's an edge there. So for the inequalities, don't forget to shade them separately as step 2. And then step 3 is your solution lies in the overlap. I'll say shaded overlap. So it's really not anything too new, it's just putting a couple concepts you've seen before together. Let's try another one. Write down this system, and then we will graph it together. I'll graph the first one in red. Again, your y-intercept is at -3. My slope tells me to rise 1 and run 2. And because this inequality has an equal sign, it will be a solid line. And I will test a point for my red line. And 0, 0 is far enough away that I'm not worried about using that. And then clean it up, and is 0 less than or equal to a -3? Well, no, it is not. 0 is greater than a -3. So I do not want to cover this spot 0, 0. I need to shade the other side. Then you move on to the second equation. That one has a y-intercept of 5, and its slope goes down 3, 1, 2, 3, and over to the right 7. So that ends up here, and that will have a dashed line. Trying my best. And I need to test for the blue point solutions, so I'll pick 0, 0. Putting it in, the second equation is 0 greater than 5. Well, no, that's not true either. 0 is less than 5, so I cannot go over my 0, 0 point. I'll go this way. And I need to extend my red line, I didn't go far enough, to see the overlap, which is way off to the right in this region here. Make sure you're showing me, and whoever you're showing your math to, that you know where the solutions are. Now, what does that mean again? Any coordinate pair under this yellow region can be put into both equations, and they will make them both true. So you have an infinite number of solutions again, but they're all under this yellow region. This example will be done just to remind us of what horizontal and vertical lines look like in an equation. And so I will start, same idea, by graphing these two equations. The first one is y is less than 5. You need to remember, either by using the idea of slope-intercept form, or the fact that all my y coordinates must be 5, or just simply memorize that y equals 5 is a horizontal line that crosses the y-axis at 5. And I need to make this dotted, so you can just erase it after the fact to get the dashed lines. Now my values for y lie below 5 because y needs to be less than 5. So you can still test a point, or logic can tell you that my values below 5 for y are down here. The second equation says that x is greater than 2. Well, that means all my x coordinates are a -2, and that creates a vertical line, and it will be dashed at -2 on the x-axis. And you could test points, or you could see logically that my x values are greater than 2. Well, where does that happen? That is to the right of the red line, that my x values are greater than a -2. Now don't forget to do something special with the overlapped region, because that is your answer set for this whole system. And there are your solutions. All those coordinate pairs underneath that yellow line would be true for both equations. Here's one more example I would like you to try. The only issue you might have is that they are in standard form. So pick a method. Either do slope-intercept form by converting them both to solve for y, or graph them using intercepts. Pause the video. Don't forget to dot or dash your line or make it solid, and don't forget to shade. Pause the video. So your overlapping region should have been in the upper right-hand corner of your grid. If you made a mistake, go ahead and dig into your work and see where it may have been. And again, you did not need to test the same test points that I did. They can be any point on this entire coordinate plane. If you have any questions, be sure to ask, but we have one more example to go through. That is the example where we need to work backwards to write the two inequality systems that created this graph. So I'll begin by labeling my equations so we can be talking about the same ones all the time. And I will start with equation 1. Now equation 1, I'm going to use slope-intercept form, and I'm just going to use a spot right now because I don't know which inequality symbol goes in this box, so I'll just leave it. But I do know my y-intercept for this equation was a -1, so I can write a -1, and then I can count my slope, which is up 1, 2, 3, and over 1 to get to my second point. So rising 3 but going to the left 1 makes it a -3 or a -3 over 1. Now let's talk about our inequality symbol. The part that is shaded for my first equation is over here in the green portion. So there's a couple things you could do. You could test out a coordinate pair and see which symbol needs to go in to make it true. Or maybe now you can start seeing things that if your y is on your left side of your equation, that you could see that this is a greater than symbol. So I will put a greater than symbol in, but because it's solid, I also know it's an equal to sign. And because I never trust myself fully, I'm going to test a point just to make sure it works. And so the point I'm going to test has to be in that green shaded region. And so let me pick maybe 2, 0 right here, just to make sure I have my inequality facing the right way. I'm doing more than I have to right now. But that's what you do when you want 100% on stuff. So -6 minus 1 is a -7, and 0 indeed is greater than a -7. So I can be relatively confident that I wrote my inequality symbol the correct way. Alright, let's do the second equation, equation 2. Same idea. You're going to use y, and I'm going to, oops, I got to erase this. And now that I'm looking at it, I should have written equation 1 without that equal sign. So I'll put it back up here. Equation 1 is truly this equation here. Equation 2, I'm just going to put a box here. I accidentally wrote that equal sign and I can't get rid of it now. So I'll look at this equation here, and my y-intercept is 2, and my slope was going up 2 and to the right 1, 2, 3, 4. So up 2 and over 4 is the equivalent of 1/2 x. You could write 2 over 4x, that's fine too. So I have the makings of my inequality here, but I need to put a proper symbol in. So I can see that the yellow region is below it, and so I can be pretty confident there too that this should be a less than or equal to symbol, but we will check it again to make sure. So I need to pick a test point in that yellow region. So we can pick any one we want. I'll try 0, 0. So is 0, 0 true? So the question is 0 less than or equal to 2. And that is correct. And so again, we can feel confident that we have written our inequality system and its inequality symbols in the direct or correct way.